Alright, problem 1 here in 10.1, comparing two proportions. So we're looking at p hat 1 minus p hat 2, where 1 is school 1, 70% of students did their homework, where 50% of students at school 2 did their homework. A counselor at school 1 takes an SRS of 100 students, and school 2's counselor takes an SRS of 200 students. What can we say about the difference p hat 1 minus p hat 2 in the sample proportions? So the set when they're combined. So what we need to do first is check for, or we follow our SOX shape. Is it normal? Well, we have to do our n times p hat and n times p 1 minus p hat for both of them to see if they're both normal. It's 100 times 0.70 and 100 times 0.30, which are both greater than 10 for the first set, the first school. We have a p hat 2 of 0.5, and n2 is 200, and multiply those. Those are both normal. So since both sets are normal and independent, the different schools, the difference p hat 1 minus p hat 2 is also approximately normal. So we have the shape. The center, remember the center of sample proportion is p hat. Mu of p hat 1 is p hat 1, which is 0.70. Mu of p hat 2 equals p hat 2, which is 0.5, and we subtract them because we're looking at the difference, so 0.70 minus 0.50 equals 0.20, 0.50, so that's our center, 0.20. Standard deviation. Now normally it's just half this, but since we have two of them, we're just going to add them both together. We add our standard deviations. So it's p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. So we substitute in our numbers, we put it in our calculator, and the standard deviation, S, because this is from a sample, is 0.0579. So we have to do this every time we want to do this. And we can't tell if there's any outliers or not because we don't have the raw data. So we can only do SCS, really. I guess that last S is not standard deviation, it's spread, but we found the standard deviation. Alright, inline skaters. So we wanted to collect data from a random sample of hospital emergency rooms. The researcher interviewed 161 people who came to the emergency room with injuries from inline skating. Wrist injuries were the most common. The interviews found that 53 wearing wrist guards and 6 of these had wrist injuries. 108 who did not wear wrist guards, 45 had wrist injuries. So I have p hat WG for wrist guard, and I have p hat NG no guard. So 6 out of 53 had wrist injuries that were wearing a guard, and 45 out of 108 were wrist injuries that weren't wearing a guard. So those are my two p hats. Now we need to check to see if we can do a two sample proportion Z interval. Well, it said that it was random. Interviewed 160 people. It says random somewhere. Random sample right here. So it is random. So let's check our normality stuff first. 6 over 53 is 0.113 times 53 gets us back to 6. Right there, 6 is not bigger than 10. We don't have to go any farther. No, the conditions are not met because p hat WG is not approximately normal, so the difference would not be approximately normal either. So we can't do a two sample proportion Z interval. That's it. Alright, the elderly fear crime more than younger people, even though they're less likely to be victims of crime. One study recruited separate random samples of 56 black women and 63 black men over the age of 65 from Atlantic City, New Jersey. 27 women said they felt vulnerable to crime, 46 of the men said this. Construct and interpret a 90% confidence interval for the difference in the true proportions of black women and black men in Atlantic City who would say they felt vulnerable to crime. So our proportions are proportions of all black men who felt vulnerable to crime who are over 65 years old. A proportion of black men, so P sub B, M. P sub BW are black women. It's a proportion of all black women who felt vulnerable to crime who are over 65 years old. So we run our tens. 46 out of 63 black men, 27 out of 56 black women felt vulnerable. So we got p hats of 0.73 and 0.482. So we run that through our tens. 0.73 times 63, 1 minus 0.73 times 63, 0.482 times 56, 0.518 times 56, and all four of these are good, so it's approximately normal. It's a lot of work to do that, but that's what we have to do. Clearly 56 and 63 are less than 10% of black women and black men in New Jersey who are over 65 years old. And it is random. So we can do a two sample proportion z-test. So our formula for confidence interval is the difference p hat b sub bm minus p hat sub bw plus or minus z star, which is going to be inverse norm of 0.05, and of course that's alpha. Try that one again. That's alpha divided by 2. And alpha in this case is actually 0.10 because we're doing 90% confidence interval. It's a little bit different. So we get a z-star of 1.645. Then we have our standard deviation that we dealt with in the last problem as well. So if we plug in our numbers, 0.730 minus 0.482 plus or minus 1.645 times 0.730 times 0.270 divided by 63, 0.482 times 0.518 divided by 56, and we get a confidence interval of 0.105 and 0.391. So we are 90% confident the true proportion of difference between black men and black women over 65 of opinion if they feel vulnerable to crime is between 0.105 and 0.39 based on our sample. So secondary question, does your interval from part A give convincing evidence of a difference between the population proportions? Is there a difference between these two populations? There is convincing evidence of a difference in two proportions because 0 is not in the interval. If 0 is in the interval, then yes, but it's not. So we have convincing evidence to say that there's a difference between these two. And we don't have to say what that difference is, whether it's black women or black men who feel more vulnerable or not. It should be kind of obvious by looking at the p hats. Black men feel a little bit more uncomfortable or vulnerable to crime, but that's not what was asked. Now if we want to do this on our calculator, just a refresher, if you're on the 84, you go to your tests, two proportion z-test. X1 was 46 and 63, so that was the black men. Black women, 27 out of 56 felt. Oops, this isn't what I want. We want two proportion z interval. And the reason I realized that I was doing the wrong one, two proportion z interval, there we are. The reason I knew I was doing it wrong is because it asked for a hypothesis. And we don't have a hypothesis when we're doing confidence. Alright, so our numbers are still in there. We just have to change our confidence level. And that's about the same thing what we got when we did it by hand, 0.104, 0.391. If we use the Inspire, same thing, statistics, confidence intervals, proportion z interval, and we put in our two sets of data. And make sure to change this, because it's not 95%, we're doing 90%. And there we go, we get the same lower and upper interval there. So that's how you can do confidence intervals with proportions.